All right, so first we'll be talking about the Osf checklist, which is the larger component of this talk. You could find the checklist at this link on the wiki. It is required for OCP acceptance. If you're submitting a server platform to OCP, you must meet the requirements of the Osf checklist. However, it is optional for the inspired tier for OCP. There are 9 sections. The sections we have in bold here are the ones we'll be discussing today in this talk, but you can read about all these sections online on the wiki or by looking at the supplier's requirements. So the ones for today are the licensing and redistribution requirements, the ownership and reusability requirement, the build system requirement, and finally the test regime. All right, so if you're worried about requiring to open source all of your firmware, don't be. A lot of people get confused between open source firmware and open system firmware. So open system firmware is the name of the OCP project. Binary blobs are allowed so long as they are redistributable and relatively, I would say, separable. The entire firmware image can't just be one big binary blob. It has to be reasonably separable. But this is an important point. There's a lot of concern about requiring all firmware be open source. The submissions we have today, there are some discrete small binary blobs such as the Intel FSP or the microcode, which isn't open source. However, it is redistributable, and that is okay. All right, so Dongwei will take it away with the next section. He'll be discussing some elements of the checklist and where it applies.
Yeah, so the OSF checklist applies to all firmware designs, the approaches, whether you're using OpenEDK2 or core boot or Linux boot or other boot, host boot, petty boot, and so on. It applies to all architectures, whether you're using x86, ARM, or Power, and it applies to compute storage servers as well as networking servers. So this particular OSF side is applying to what we call the host firmware or system side of the firmware. It does not apply to the following cases. So it does not prevent the suppliers from adding additional features. So anyone could add another, additional value-add features and so on. It does not prescribe what may be used in production environment. Right, so you can make different choices there. It does not apply to OCP platforms other than, the list we talked about, the compute, the storage, and the networking servers. And it does not apply to device firmware or BMC. So the BMC situation is a bit interesting. So there's a separate open BMC effort, and the BMC topic is actually falling under the OCP hardware management project. So you should follow the guidance is there, and there is also a checklist for Redfish, right? And then the OpenBMC is a Linux Foundation project, and I think there's still an encouragement for people to utilize the open source or open BMC code as well. So the core goal of the OS checklist is that 3 things, right? You can construct whether it's from the open source or whether it's from some of the binary blobs, you can construct it, and then you can install, and also you can redistribute the firmware. So I'm going to talk about the construction side. So the top level build script shall be the only script that you use to run and fetch all the blobs or the source code from the sources, right, from the main line or from wherever you get the blobs. So the top level build script may invoke other scripts and utilities to carry out the main functions. And so the emphasis here is there's only one script so that it's easy for people to construct. And then you build and update the utilities must be also open source so people can do the build and do the update. And they must be a redistributable binary which must be run natively under at least Linux or Windows. And so here are some of the examples of how you can construct it, right? There is this GitHub repository for OCP and for OSF, actually. And so you can, this is an example of how you probably could, go to the directory of the sources and directory of the binaries to, so this is basically showing you that the source of the firmware may not completely be open source. You can actually download from some of the binary blobs. And here's another example of the Wewing contribution from the Delta Lake situation, right? So you can see there is a top-level build script that could download the source code from upstream projects. We would want to encourage people to still use the upstream projects as the main place for the main repository for the source code, right? So you don't want to deposit those kind of things into the OCP repository. But this build script is going to be able to grab these mainline source code from the main repository. And I think, as you probably heard earlier yesterday, that Ampere also contributed a Mount Jade platform built by Wewing as well. So you can see this is across the architecture contributions. So let me hand off to Reddy to talk about the installation and so on.
All right, thanks, Don. Okay, so there are three aspects of the checklist, as Ryan and Don talked about. One is you need to be able to construct it, then you have to be able to install it, and the third one is redistribute. So the install element is, it has to be, you should be able to actually take the submission. This may include the scripts, of course, installation document. If there are any binary components, including microcode, you need to be able to take all those things and be able to actually install it, in a completely automated fashion, because we don't want to actually take it one portion of the firmware component at a time, and we don't want to be actually doing that work for somebody else. So whoever is submitting, they need to be able to submit the entire package, and we need to be able to actually kick off a script, and then you need to be able to build a binary blob or the BIOS image that you can actually flash. That's really the key theme behind installing it. Once you install it, the bigger element in this checklist process is you need to be able to redistribute it. And the rationale behind that one is it has to be open. And if it is open, that means you will be able to install it, consume it, as well as be able to actually package with your own additional components. You should be able to redistribute it, right, without any licensing baggage associated with it, right? That's really the key theme. This is important for circular economy as well. The preference when we actually talk about contributions to the OSF is ideally we want everything top to bottom open source. But we know that there are certain components that vendors want to protect through the binary blobs. But the binary blobs need to be able to, we should be able to redistribute the binary blobs. So the licensing restriction should not be in place. If that is the case, then we can't really approve. So the key theme is, as much as firmware, it should be open source, but if there are certain things that you need to have a binary blobs, that's okay, but you have to be able to redistribute it, right? So that's the theme. How do you verify them? Now, you essentially get the collateral that includes all the pieces of building the firmware and the documentation and the test cases, and we need to be able to actually build and image, program the server with the whatever image we build, and we need to be able to boot the platform, and you need to be able to at least do primitive checks. It's not going to be all the complete validation, but we need to be able to actually do the primitive testing to make sure it is really working, right? Is it enumerating the cores and PCIe devices and so on, and make sure at least it's working. You can image, you can flash, you can program, and you can actually boot, see the operating system, at least run some commands. That's really the focus of the verification. Testing, we do have few things that are actually part of the checklist. Things like you need to be able to do 100 consecutive hard reboots or warm resets without any issue, right? Of course, we won't be actually testing them live, but we want them to actually ensure that they have tested it and it is actually very reliable, at least 100 consecutive reboots. That's really the key theme. In summary, like Ryan mentioned, OSF checklist criteria has been instrumented this year, later part of this year, as the criteria for you to actually get OCP acceptance. There is an open BMC one, there is a security one, but OSF is one of the building block components. That includes constructing the image, and then you actually programming the platform, and then redistributing the image to the whomever you prefer. Right. The key thing is, I hear a lot of talk about OSF means open source firmware. We don't call it open source firmware because there is an element of a binary angle to it, open source plus binary aspect to it. So we consistently want to re-emphasize that it is open system firmware. Take a look at the Experience Center. I think there are a lot of companies who put in a lot of effort to actually give you the perspective on how OSF is actually shaping. There are core boot demos, Linux boot demos, there are main platform demos. Would love you guys to actually take a look at the Experience Center demos because a lot of people actually spent a lot of time and energy to showcase what we have out there today. Like Ryan said, we have the wiki. There is a mailing list. You should subscribe if you're interested in getting the updates. Join us on the weekly calls. We are looking for more and more volunteers and contributors to really shape up the OSF forward-looking agenda, all right, on the strategic front. And then, of course, like Ryan said, there is a GitHub where we actually have the already submitted platforms.
All right. And if you haven't seen it yet, an Eagle Stream demo has just showed up in the Experience Center.
Yeah, so I think Jonathan is right here. So we have I don't know how many of you heard about or attended the Compute Express Link software-defined memory related talks. Facebook has given a couple of talks today, and then we had a SDM Future Technology Initiative. Part of that initiative is that we want to actually bring up the open system firmware to enumerate the CXL devices and be able to actually show the memory and be able to consume that is coming from the CXL attached memory buffer. We just got that in the Experience Center that actually works quite well, and I'm happy to say it is core boot. That has been my dream project for quite some time with Facebook and Jonathan and few others, including 9 Elements and few other companies, Maven and so on. But I'm glad to see that we actually have it up and running. Okay, so we want to spend, I'm not sure exactly, we have around 9 minutes or so. We really want to get your perspective on what OSF should be focusing on for the next 6 months. We have checklist-related activity going on. So we looked at checklist as a starting point to make sure at least we start off with the server platforms and make sure we have vendors getting the checklist process submitted and getting the approval. Like Dong said, we essentially have Delta Lake, Intel platform, Ampere platform. There are a few other platforms in the pipeline that are actually going through the checklist and approval process. That's really excellent. From all the work that OSF community members have done, I think we achieved quite a bit of progress. What we are looking for is what do we do beyond checklist, from a strategic perspective to add value to OCP and open system firmware. So I'm going to leave it as fairly open-ended, and give us some thoughts on what we should be focusing on. Anything that you have an idea. It's fairly open-ended, but would love to get your feedback. What the community should be focusing on.
I have a comment or question on this.
Yeah.
Because you're kind of having a hybrid of some open source with a kind of recipe for building binary blobs.
Right.
Is there, and you mentioned that there's the OCP Marketplace and GitHub, is there any kind of version control or signing for these binary blobs that are in place? And like any kind of structuring that we can put on releases or documentation of binary blobs?
Ryan, do you want to answer?
So currently there isn't a release process for these binary blobs. So one example is the Intel FSP. Intel typically releases these binary blobs publicly on their own Intel FSP GitHub. And they have release notes there, but there aren't any release notes in the OCP GitHub itself. It isn't something we require today. And in terms of the other part of your question, in terms of the source control and the build system for binary blobs, essentially, our main, like the first step we want to take is making it as easy as possible for the suppliers to release their source code publicly or redistribute their binary blobs publicly. We're trying to limit the amount of feature creep or excess requirements in the checklist. We want to focus on that specific point for the first version of OSF. We're hoping for future versions we could incorporate items such as that, possibly release notes and other things. And I think that's something possibly we can do in version 2.
Yeah, I mean, the build collateral itself will include details of what versions it is actually pulling. If it is a source code based pull like core boot, you essentially have a tag, so you can actually get a little bit of clarity on the version control, including the binary blobs. But are we really enforcing the version control? At least we are not completely enforcing that. The rationale behind that one is we really wanted to encourage the vendors to start submitting, and then there have been some concerns about how big of a checklist it is, and they will have to do that for security, BMC, and the platform. So there has been a little bit of concern around the amount of work they have to do. So we are trying to balance between how much of process we need to actually enforce versus how easy it should be for them to be encouraging to submit the checklist and go through the approval process.
The final part of your question about the signing, currently we have no requirements on signing. Besides, it should be possible for whoever purchases the server to build and place their own firmware on that system without having the vendor sign their firmware for them. There has to be some mechanism to allow some sort of modification to the firmware and place it on the system. The ownership model can't prevent the end owner from doing that.
In my opinion, I understand the reason you can't you are open system firmware, not open source system firmware. And I think that could be a value add that could add at least some control and put a floor on how binary blobs are managed.
Yeah, very good point.
And I think that
we should,
and I understand your point on making it easier to distribute, but I also feel like this is a kind of thing that actually can be done. It's like a value add as opposed to a carrot, or a stick that you're using to say, oh, you need to do all these things. Well, it's like if you put this up here and you're a verified member, you get to these things.
Right. Yeah, a very good point. Yeah, I think we should consider that. Yeah, totally agree.
Thank you very much.
Thank you.
So maybe just to follow kind of on that, like maybe what you can do in the next 6 months is actually work on guideline on what you want to be inside the blob and what you'd rather have as open source. So like guideline, okay, the blob can do like the memory control initialization or this or that thing. But for everything else, we would like you to be open source. And if you're not open source, kind of explain to us why you're not. I don't know, like just trying to give an idea of what you can work on.
Yeah. Thank you. All right, any other feedback?
Hi, how's it going?
Yeah.
Jack here. I had a quick question on deployments and, what flavors are out there too, in terms of I assume somewhere inside of Google or Facebook, this is running, right? And which version of it? If that's something, that could be shared, just curious, how far along it's gone.
Yeah, I think it really depends on what these vendors are willing to share. And we normally, encourage them to actually come forward and talk in the weekly calls. But this is something that we have been pushing very hard. the production implementation proof points, not just the lab related. You'll likely see more and more over the course of next 1 year to 2 years, because the firmware is something that a lot of customers don't want to take the risk, and it's been there, UEFI-based code base has been there forever on thousands of devices, so there is that element of resistance to move to more open model, right? Checklist is essentially the first step in getting there, right? And then silicon vendor support obviously need to be in place. OEMs and ODMs need to support as well. So I think that whole ecosystem collaboration is coming together. We should see more and more.
Thank you.
Yeah.
I figure if no one else is asking
Yeah,
questions,
please,
I'll
yeah.
ask another one.
Yeah.
What, in your experience, what do you think is the biggest blockers getting in the way of adoption from vendors? Or some possible ideas being, is this a process hurdle? Is there technical constraints, or is it concerns about competitive advantages?
Dong, do you want to take that? I don't want to put you on the spot.
Yeah, I think it's interesting, right? I mean, I think that there is actually a pretty wide adoptions right now. I mean, a lot of people are willing to do that, right? I mean, I showed a couple of examples already. Certainly, you know, there has, in the past, there has been concerns about, you know, whether this is, you know, this contribution is enabling the competitors, quote unquote, right? But I think, you know, in a sense that, you know, OCP is about, you know, making sure the users are going to be able to, you know, manage the system, update the system, and, you know, fix the security vulnerabilities in time quickly to solve these problems. And I think, you know, if you go to some of the vendors out there, right, they are actually considering and adopting this strategy. So it looks like.
I just thought I'd mention, because it was the, hold on. So it's worth mentioning, just because it was the question, outside the domain of OCP, there are products that follow these guidelines pretty closely. And the first one that comes to mind is every Chromebook.
Right.
So Chromebooks are compliant with this model.
Right.
And actually, and to some extent, Chromebooks inspired this model. So it's 100 million, there are 100 million examples out there.
Yeah, very good point.
Yeah, in my ecosystem, I might want, you know, I've been dealing with a lot of the edge devices and so on. The silicon vendors are willing to, you know, this is outside of OCP, right? But the silicon vendors are willing to, you know, upstream their whatever U-boot, you know, EDK2 code upstream and open source. We have been, you know, delivering a lot of these products that way. So.
Yeah, very good point. Yeah, we do see the code boot-based implementations in the embedded appliances. So I guess we are out of time. Thank you.
Thank you.
Let me introduce the next